In this video, I'm going to demonstrate an example of redesigning a database to have multiple tables with relationships. And the goal of using relational databases is to store our data as efficiently as possible. And so often, in order to achieve that goal, we end up having multiple tables. So in this table, as it is right now, or in this database, it's a single table, the customers table. And if we look at these first few columns, these are all related to the customer. Okay, everything from customer ID over to phone number is information about the customer. So that is a good set of data on a single subject. The rest of the fields in this table relate more to the boat and the purchase than directly to the customer. So two things that we watch for. One is repetition. When we have repetition in a field, we need to ask ourselves whether it's appropriate to create another table for that data. So when we look at the boat type field, we do have the same pieces of data repeated many times. So there are a certain number of boat types that we sell, and we're reusing that information over and over. So in this case, I would suggest it's appropriate to create a table that has our boat types. Now, another example, city and state both have repetition as well. And so we always have to make these decisions. In the case of state, even though we actually only have a single state, it doesn't look like anyone from out of state has purchased a boat. It's a very small piece of data. It's the 2-character code for the state that's repeated, and so potentially not worth building a table to store all of the states in. And so in this case, we're going to leave that field as is. The same thing is true for city. We do have some repetition in the city field, and yet it's often not more efficient to build a table of cities just to save that time. You could make the judgment call that you want to build a table for cities, but it often is not done. So we're looking at, we want to build a table for our boat types. Doing that is going to reduce the amount of space that's needed to store this data, and it's going to increase our data integrity by reducing our chances of error. Now, the price financed and amount financed fields are more about the purchase of the boat than the customer themselves. These are not fields that describe the customer. These are fields that describe the boat. And so that's sort of a question that we can ask ourselves. The subject of the table is the subject defined by the primary key. So in this table, the subject is the customer. And so does a purchase price or an amount financed describe the customer? No, it doesn't. It describes the purchase or the transaction. And so again, that's one way that we can possibly identify that we maybe need an additional table. These fields are not directly related to the primary key or the subject that's defined by the primary key. Another thing that we would see that happens, and you want to think about your data and sample data and what you're putting into the database. So let's say that we have a customer that is going to come in and buy another boat. Okay, so actually I'm not going to choose the last customer because I don't want the records to be right together. So let's say that Ricardo Diaz here, number 53, is going to come in and buy another boat. So he has a sailboat, but he's coming back to buy a fishing boat. If we leave this table the way it is, when I go to enter that purchase, I'm going to have to enter that individual's name and address information again in a new record to enter his new boat. And yet when I do that, I've now duplicated his customer information. So if that person changes their address or their phone number and I go to update their customer information in the database, I have to go and find it in more than one location and make sure that I get those updates in every location throughout the database that references that customer. And so our goal is to store each piece of information a single time, but we can reuse it when we need through relationships. So two things that we need to do. We're going to create a boat type table to eliminate this redundancy, and we're going to create a table for the purchase of boats in order to, again, eliminate potential redundancy and to get this data into a table that is fit to its subject. We will create those tables, and as we do it, I just want to point out this is obviously a very simplified database as is, but as a designer you might ask yourself what additional information you need. For example, with a purchase you would probably have the date that it was purchased and additional information relating to that sale or transaction. But in the interest of keeping it sort of simple and feasible, we'll stick with this purchase data that we have. So going from a single customers table, the redesigned database might look something like this. In this database, there are 3 tables. So there's the customers table, and the only fields in the customers table describe the customer. Okay, so I'll open that up. And again, it's just the name and address and contact information of the customers. We have a boat types table, and this simply has a boat type ID and a boat type. We often call small tables like this a lookup table. So if I open the boat types table, we have our fishing power sail boats. We have ID4 for other types of boats. And if we start selling an additional type of boat, we create a new record in this table to identify that new boat type. Now, in the middle, sort of, we have our boat sales. So boat sales gets a unique ID. Okay, the purchase gets a unique ID. It uses the ID of the customer to reference the person that bought it, and we reduce the amount of data that we're storing by just storing the customer ID. We have our boat type ID, and again we reduce the amount of data that we're storing by just referencing the boat type ID. So a fishing boat is type 1, a power boat is type 2, and so on. We just store the data from the key field. And just as a reminder, it's a primary key in the boat types table. It's a foreign key in the boat sales table. Customer ID is a primary key in the customers table, and it's a foreign key in the boat sales table. And then as well, related to the sale of the boat is the price, whether or not it was financed, and the amount of the purchase that was financed. So when I open up the boat sales table, it looks like this. Each sale has an ID number. This is like an invoice number or just a unique identifier for the transaction. The customer is referenced by their ID, and the boat type is referenced by its ID. Now we can take this a step further so that we see potentially the name of the boat type ID or something more descriptive of the customer, but we change that in just the display. And so the data that's being stored is minimal. Instead of storing fishing, the word fishing, over and over and over again, it's just storing the number 1 over and over and over again. And so it reduces the amount of data. And then we have our financing and price information over here related to the purchase. And so if I have a new purchase, I enter it. I enter the customer ID, the boat type ID, and the new financing information. So we've gone from a single table that was sort of misleading in that it was called customers. So even though this table is called customers, it actually has a number of different types of information: customers, boats, and purchase information. And we've split that into 3 tables: the boat types, the customers, and then the sales, which ties a customer to the type of boat that they purchased and includes that financial information. So this is now a better designed relational database. There are more changes that we could make, but we're getting the data broken up into the appropriate tables.